definitely want to get a chance to get this presentation and conversation started. It looks like we have about 40 people joining us, so that's great. For all the participants here, we have a really excellent panel of speakers joining me today that are bringing some really diverse experience and perspectives. We'll get a chance to meet everybody through introductions, but I'd really like to have this be a very conversational session, and would encourage people to use the chat function on the side panel to upload questions, thoughts, whatever kind of areas of interest that you'd like us to speak to. We do have a broad range of experts, and so let's tap into that. So I'll let the speakers go through and sort of introduce themselves, and then we'll address those questions as a Q&A in the second half of the session. But please use that chat panel to do it. We'll go through in a bit more detail, but just you can see the 5 speakers that we have listed here. Myself, Calina Ferraro with Integral Group. We have John Elliott with Lawrence Berkeley National Labs. Jasmine Lomax with Kilroy Realty, Shawn Hesse from the International Living Future Institute, and Jim Hanford with the Miller Partnership. And today we're here to talk about the future of commercial buildings. And I think this is a very positive session, certainly for myself, and I think for the other speakers here. The future of commercial buildings and the conversation around electrification of commercial buildings really is inspiring. I have this image of the blue marble from the moon, and I think it's really relevant if you think about sort of the movement that was afoot back then to get to the moon and really pursue new technology and science, and the rate of change that happened sort of once that started moving. And I think we're seeing similar movement now as the buildings transition to this new generation of electrification. It's been sort of a long, slow conversation that's been happening over decades. And then I think just within the last few years, we've all seen a lot of traction really pick up. And I think that's really inspiring myself. And I think there's a lot of sort of inspiration to take to that for our projects moving forward. So what I'd like to do is we're going to go through and let each of the panelists here each introduce ourselves, sort of what we do and our individual backgrounds, and really what inspires each of us for this next generation of buildings that we're designing or retrofitting and bringing online right now, primarily focusing on these new construction projects in the commercial space. So just to get started, my name again is Calina Ferraro. I'm a mechanical engineer with Integral Group. I'm a principal leading our San Diego office. And the image I put on the screen here is for our J. Craig Venter Institute. This is a lab facility in San Diego, so it's right in my backyard. And this was the first zero energy lab designed. It's a zero carbon design building. And we did this back in 2013. So when we did this project, it was really doing something new. There was a question as to whether we could even do it. We really felt like we were pushing the envelope. And I think we've learned a lot in the process of doing it. And it's now making the design of these projects a lot more feasible. And to have done it back in 2013, it means that now when we're in this climate where so many people are talking about buildings and can we do it and is it feasible, it's really great to be able to have this example to point to and to say that yes, we can, and to really motivate that conversation and engage people that it is doable. We're not trying to be guinea pigs with buildings anymore. We're demonstrating that this has been done and can be applied to building types as challenging as lab facilities. And so I think it's really inspiring to see sort of what we've done in the past and understand that that's a launching point and that buildings in the future can really just take this and go even further. So that's where I'd like to start. And I want to pass it around the group here to my other presenters to have a few minutes to introduce themselves. So go ahead, John.
Great. I'm John Elliott. I'm Chief Sustainability Officer at Lawrence Berkeley National Laboratory. And I really am inspired by the future in which buildings will be efficient and electrified and intelligent. You know, new construction is a real opportunity for innovation. You kind of open a door, you can peek through, and you can see the trend needed across the entire building sector in order to meet our climate targets. So I'm an owner and operator of buildings at the lab. So we're a research campus with a daily population of about 5,000 people. And we're really seeing this electrified, this efficient and electrified and intelligent future really right now. So if you take the example that's in the slide, Integrative Genomics Building is what it's called. This is a new building that we've been operating for just about a year and a half. In many ways, it was inspired by the Ventnor Center too. We visited that building in design. So it's very efficient. It beats energy code by more than 30%. That's ASHRAE 90.1. But we really drove performance in this building by setting whole building performance targets. That is, we asked the design team to tell us how much energy this building would consume in real life in operations, and to prove it using minimum energy performance target and a stretch target. In this case, the design team, which was Smith Group and Integral, brought us a building that actually was better than the stretch target. And as we've dialed it in and operated the building for a year and a half, it's actually doing even better than that. So this building consumes about a little less than a third of the energy of the building that it replaced, a leased building. So same program, a new building, and about a third of the energy use. It's about 106 kBTU per square foot per year. The building is also electrified, all electric space and water heating. It uses very efficient heat pumps. Most of the heat that we use in the building is recovered. It's recovered from the cooling system. So cooling actually pulls heat out of the building. And instead of doing what's often done in the building industry, which is you take that heat and dump it out of a cooling tower into the atmosphere, and then you go someplace else and turn on a natural gas tap to produce heat, we actually just use heat pumps. It moves that heat from the cooling system over so that we can use it for space heating and for industrial heat. That's a very efficient system. So the heating plant in this building starts off with about half the greenhouse gas footprint of a typical natural gas system. And over time, you get that big benefit as we decarbonize the grid. That footprint will go away over time. The building is also very intelligent. And I think what I'm seeing as a transformation in this space right now is that we don't really think about installing or building intelligence in the building. We sort of build in flexibility and feedback, and then we integrate the building to, in our case, a campus-wide operating system. You could think of this as like a cloud-based operating system, and then we build applications on top of that kind of standard data model. In much the same way that we've seen this kind of architecture transform mobile devices, we're also seeing a drastic increase in our ability to scale our energy management and be much more innovative. So this is an example building. It's kind of set a standard for our new buildings at the lab, and we're continuing these ideas. So we've designed another laboratory building of similar size and another multi-purpose facility. It's a clinic, event space, and a cafeteria. It will replace our campus-wide cafeteria. All those buildings are efficient, electrified, and intelligent. So yeah, I'm inspired by this. I'd argue that the future of commercial buildings is really happening now, and that we need to keep pushing and innovating. Every building needs to be better than the last, but that work is well underway.
Great, thank you, John. Next, I'd like to give Jasmine a chance to talk about what she's doing over with Kilroy.
Awesome. Hi, everybody. I'm excited to be here today. My name is Jasmine. I'm a sustainability manager at Kilroy Realty, and my background is actually in construction and construction management. So my passion is in building, and I always sort of found it challenging that when we were already constructing a project, it was kind of too late to make these sustainable and innovative decisions. So I ended up switching over to development, which has been wonderful. And you can see one of our latest new developments here in the background is on Vine in Hollywood, which is an all-electric building. The part that inspires me the most about the future of commercial buildings is how collaborative that process is going to need to be. Whether people want it to be or not, it's super necessary. Integrating various features, whether it's new technology or intelligent aspects of buildings like John was just talking about. And so that's where I really find the inspiration. And it just becomes really intersectional at that point, where you're not just thinking about the building, but everyone who's going to be interacting with the building and the community around it. So yeah, that's my perspective.
Thank you. Yeah, we're really glad that you and John both bringing sort of the owner's perspective. It's a very different position to be in than, like you said, either on the design side or the construction side, which is sort of happens either later in the process or before people move in. So thank you. Next, we have Shawn Hesse from the International Living Future Institute. Shawn, go ahead. What inspires you about the next generation of buildings?
Thanks. Yeah, so I'm as the director of business development for ILFI. We're a nonprofit, right? We develop certification standards for buildings and products and organizations, and we're really driven by our mission, right? Catalyzing a world that is socially just, culturally rich, and ecologically restorative. So there's a lot about it that inspires me. That's why I came to ILFI. I practiced architecture and did sustainability consulting for about 15 years before coming to ILFI, and the mission here has really captivated me and brought me in. And I think part of that is the way that ILFI is focused on this is in order to really catalyze that transition, we recognize that we need to demonstrate a positive vision of the future, right? That we're not just looking for a world that is a little less bad than the one that we currently have. We really want a world that, we ask this question all the time: what does good look like, right? So we started this work with the Living Building Challenge actually in 2007, and since then went on to create other certification standards: the zero energy certification, zero carbon certification, core green building certification, and all of them require that projects be 100% electric. So no on-site combustion for any of those certifications. And for me, and I think John kind of already touched on this, but when I think about the prompt of the future of electrification, it's like, well, that future is already here. We're already living it. When we launched Living Building Challenge about 15 years ago, right, it was requiring projects to have zero on-site combustion was a radical idea. And now, this is being integrated into building code. For us, what we're showing on the screen here, these are buildings that are not only all electric, but they're certified as having produced more renewable energy than they use, right? So this is not only 100% electric, it's 100% renewable electric. And these, you can see we've certified over 150 projects. They're all over the world. They're in every climate zone. They represent every typology, from existing building renovations to ground up new construction. We've got projects that are residential, single family residential, massive commercial real estate projects, speculative development. And so it's really, for me, it's inspiring to see kind of the range of what can be done with this. And again, not just stopping at an end goal of saying, well, the building's all electric, but actually going to a place of saying the building's all electric and that electricity is carbon free. Some of the projects that you see here on the screen in the upper right, that's the Bullitt Center. That's in Seattle, Washington, right? A speculative office building, fully leased, produces more than 150% of the energy than it uses over the course of the year. Below that, kind of clockwise, that's the Candida building for innovative sustainable design on Georgia Tech's campus in Atlanta, Georgia, right? Super hot, super humid, able to meet all of its needs through that PV array that you can see pictured there. Next is the Sustainable Buildings Research Center. This is in Wollongong, New South Wales, Australia, right? And again, this is a building science technology research facility where they're simulating energy modeling and teaching the kind of future of sustainable building practices. Next is a project that Google certified. So this is Google's office in London. It's called 6 Pancras Square. This is also our first zero carbon certified project, which looks at not only operational energy and certifying that that operational energy is being met with renewables, but also certifying that they have offset all of the embodied carbon emissions related to building material products and you know, mining, manufacturing, shipping, installation of all of that material. So really being responsible for the full carbon footprint associated with that project. Underneath my little title there, you can see there's a single family residential house, but you know, that's in a desert, the high desert of Oregon. Above that is SFO, the San Francisco Airport Airfield Operations Facility. And then above that in the upper left, you can see Silver Oak Winery, and that's a full production facility. They produce wine. They not only produce more renewable energy than it takes to manufacture the wine, but all of their process heating, boiling all of the water to clean all of their equipment, it's all done with electricity. And you know, and then they've also balanced out the water needs. So they have over 100,000 gallon on-site water storage that uses well water and make sure that the watershed itself is in balance. And then the very top, the last project there is an example is Rocky Mountain Institute's headquarters in Colorado. And again, you can see, you know, snowy Colorado, able to meet all of its own energy using on-site renewables. So these are, you know, for me, the thing that's inspiring is we used to have a conversation about trying to convince people that it was possible. And now I think we've gotten to a place where we're well past the conversation about whether or not it's possible. And we're now even crossing the threshold of not only is it possible, but you know, is it possible here, right? We've checked that threshold. And now we're starting to get questions about the question of scale, right? Oh, well, you might be able to do it for that small building, but what about these, you know, big dense urban projects? Or what about, you know, projects that are high energy use intensity projects? And more we're seeing projects come through that are 1 million square feet or more. We're seeing projects in extremely dense urban locations. We're seeing projects with really, really high energy use intensities, wet labs, et cetera. So it's a really exciting time for me to see that not just building electrification, but going after zero energy certification for these projects and seeing it scale around the world is really amazing.
Thanks. Yeah. Really valuable to see all of those different typologies and specifically to see all the different locations. I know the example I showed at the beginning, the J. Craig Venter Institute, that's in San Diego, which, you know, again, in 2013, to do zero carbon there was pretty novel. And then these just demonstrate that, you know, San Diego might be the easiest place that we could do it, but it's certainly doable, you know, in lots of different locations as well. All right. Thank you. Okay, so then last person I want to get introduced here is Jim Hanford from the Miller Partnership. Go ahead, Jim.
Thanks, Calina. Excuse me. So I'm Jim Hanford, a principal and sustainability team leader at the Miller Hall Partnership. We're a 100-person architecture firm with studios in Seattle and San Diego. And we work up and down the West Coast primarily, but also nationally and also internationally. We're doing some work with the State Department right now. And our firm is committed to helping our clients and the places we work in meet the climate goals that they have. So we use Architecture 2030 Challenge targets for our design projects, and also on not just on operational energy and emissions, but also on embodied carbon. We work to educate those we work with on the benefits of zero carbon design. And we also advocate in the regulatory arena to kind of support this transition to the future of buildings. And so what excites me about this new generation of buildings is that derives all of their energy from grid-based and on-site renewables is that these are the future. And I'll just kind of, I feel like I'm going to be a bit of a broken record following Shawn, but I'll I'll proceed with what I had in mind, and we can take it from there. So these buildings are super efficient. They're smart, they're climate responsive. They combine good technology and passive design, and they're tuned to occupant behavior. Another kind of quality is that they are integrated. They really support decentralized energy and resilience, and use the landscape of the built environment for production and not just kind of spreading energy production across kind of our rural areas. They're money smart, so they're taking advantage of the availability of money to grow efficiency and renewable energy at the same time. And they're also good for people. So because of the way high-performing buildings are required to be designed, they really have us as designers focus on human needs, and so they end up being better for human health and well-being. And we also think they kind of help develop a good job economy in the regions where we work. So those are the kind of benefits of these buildings that we're talking about here. And I want to be clear that, electrification for electrification's sake is not really the goal. Efficiency is equally or more important than just electrification. So it's imperative that we drive down energy use so we can have an equitable access to this clean energy that we're developing. Today's theme about electrification, I think the design challenges aren't huge for that aspect of it. There's some things like space allocations for MEP systems and cost impacts on the electrical side, but as with any aspect of high-performing design, starting with clear goals at the beginning is important, and kind of taking a standard design and then working backwards to develop a more efficient electrified building is not really the most cost-effective approach. So starting in the right place is important. So these, again, are a few examples of projects that we've done, high-performing all-electric buildings. In the upper right is our office building in San Diego, which is Living Building Pedal certified and net zero energy. And the bottom right is an archive and office building that we recently completed for the County of San Diego. That's a net zero energy facility. Upper left is the Bullitt Center, again, first commercial living building project in Seattle. And then in the bottom left is the Hans Rosling Center at the University of Washington. So it's an almost all electric research center on the University of Washington campus. Has a little bit of connection to the central plant, but it's almost all electric and a high-performing building as well. So I hope the main takeaway from this session is these projects are out there and doable. And I think, with the passing of 2020, and now we have 2030 in our crosshairs, we're all realizing that what we're designing today is those buildings that are going to be occupied in 2030 and kind of forming the basis of the building stock in 2040 and 2050. So I think we're all realizing now that we're building the future. Thanks.
Jim, I'm really glad you included that project in the bottom left there that you described as being almost all electric. I think sometimes we have this tendency of getting kind of tunnel vision. We get the full certification, or we're going to get full all electric or full ZNE, and if we can't hit that, then we're just going to scrap it. And so I think it's really important to remember that designing a building that is really efficient and high performing and good for people, like you said, that's a really worthwhile design, even if you're not hitting 100%. So it's a good reminder. Yeah. Also, the fact that we are designing for people, right? We're not designing boxes to keep thermostats on walls happy, that we are designing comfortable, beautiful spaces for people to be in. So that was a really great overview of the expertise that we have on this panel here. And then really, I want to just take the rest of this session and dedicate it to having a bit of a conversation amongst the five of us, and particularly getting input from the four of you. I have seen a couple of questions come in from the chat, so I'd say let's address those first, just to make sure that we get a chance to answer them. And if more questions come in, that's great. And if not, I'm sure between the five of us, we can roll through a few different questions and really discuss some of the key topics that we've come across in our various careers. Just a couple of technical ones that I saw roll in, Shawn, as you were speaking, and I don't know if you know these figures off the top of your head, but as you were going through the different typologies and locations, There's just some questions about sort of building size and scale that was as part of that. So can you speak to sort of the upper end of what's been certified at this point at both square footage and building height?
Building height, less so, but I just recently was looking at the averages of projects kind of all time across our portfolio. We have about 800 projects that are registered and pursuing certification at various stages in the process. And kind of lifetime across that full cohort, the average project size is around 60,000 square feet. Now, when I mentioned, if you look at just in the last 12 months, the average project size of that cohort is well over 100,000 square feet. It's closer to 250,000 square feet. So when I mentioned, the kind of scaling of the adoption of the programs, to me, that's what I've seen is, we went from these relatively small demonstration projects for, environmental learning centers to we're now talking to, some of the largest real estate development teams in the world, and thinking about what it means to pursue this in their portfolio. So it's a pretty dramatic scaling.
Yeah, no, that sounds like it. From the height standpoint, I do remember one of the things that was when the Bullitt Center finally got certified, the height of that building being pretty, like, a specific point of that. And Jim, maybe you can speak to that, since I know Miller Hall designed that project. It's how many stories is Bullitt Center, and what was the process of finding enough roof space to make sure that you were generating enough?
Yeah, so sure, it's a 6-story office building, and one of the main goals of that project was to be a replicable model. So it needed to follow a typical commercial building development kind of model for the city of Seattle, and so the owner did not want to back down on any of the kind of allowable FAR for the site. So filling out the full 6 stories within the allowable zoning envelope was important. So that made us have to design an array that was actually bigger than the piece of property, and so it actually overhangs the right of way a little bit on 3 sides. And solar is not the best thing in Seattle, believe it or not. It's I mean, it's great, but Seattle's not your best solar resource in the country. In fact, it's probably one of the worst places in the country, but the project does show that it's feasible to develop a fairly tall, mid-sized urban office building in the worst solar climate in the country. So that one was really about driving down energy use for sure, and using a variety of strategies, design strategies and behavioral and kind of operational strategies to get the energy use down low enough to make that feasible. So it's really become a model in terms of efficiency and also kind of right sizing for on-site renewables.
Great, thanks. We have a question in the chat, specifically talking about the importance of cooling equipment maintenance, coil cleaning, filter replacements, and the impact of that from an operational standpoint and actual usage energy. John, I wonder if you can speak to that now that you have your genomics lab building operational, and it has been for, I think you said, over a year now. What types of operational maintenance are you finding? Are there specific elements that you notice have more significant impacts on the energy consumption than others? I guess maybe if you can just paint us a picture of the operational standpoint of these buildings.
Yeah, I don't have a particular comment about like coil cleaning, but I will say we put a lot of attention to operations and maintenance, and in fact, we've developed a whole approach, kind of called ongoing commissioning, in which we are constantly looking at buildings, identifying faults with them, and selecting. We have a big backlog that we developed, and every month we go through a little cycle where we pull out some things to fix, and then as a team kind of address those. So we see, that ongoing maintenance is really critical to maintaining performance all the way through. It's a very important part of it, and it's very important when you think about new construction to really think about the year after construction and then all the years after that, because you need to put a lot of attention into that process as well. It's not all just going to happen with the new building.
Right. We want these buildings to be around for a long time. It's no good to have an energy efficient building if you're going to replace it in 10 or 15 years.
Yeah.
All right. We have a question about regulations and what entities and policymakers can do to help that transition. Jasmine, I wonder if, from your perspective as a developer, I know Kilroy across your portfolio, you've made commitments to, achieving voluntary certifications at different levels, but obviously you're also working within different regulatory frameworks, developing new properties. So I guess just do you have any sort of experience in how changing regulations have informed your policies in the past? And really, from your perspective, what types of changes could those government entities potentially make from a developer standpoint that would inform those developments and maybe change the goals that you set for the design teams?
Definitely. I think some of the more recent regulations have, especially in California and a little bit on the East Coast, have been really supportive of higher sustainable building practices and electric buildings, carbon neutrality, reduced embodied carbon footprint. I think they could do more. I know there's like a balance between keeping everyone happy and building owners and just citizens and whatnot, but I think it's really important to really start putting the planet first, and then of course people, and not really so much worry about profit as far as those regulations. And I know at Kilroy, we sort of spearhead some of these more innovative, sustainable practices. We're always looking for more efficiency projects, even outside of regulations and support from other public or government entities. So that's sort of my thought. I think there is that support there and things are sort of starting to happen, but there could be a lot more. And I think there's a little bit of apprehension there as far as policy and worrying about, well, if these entities don't like this, then it won't get any support, but just make it mandatory.
Right. I guess, does anyone else on the panel want to chime in? I know, Jim, you and I on the design side, we work within these shifting regulations and, also take an advocacy role. Shawn, I know ILFI has a strong advocacy position as part of the certification. Would either of you like to add to Jasmine's comments?
I could chime in. I mean, I think regulations are important in I think on the West Coast in California and Northwest, I think regulations have actually really helped develop a a culture of high performance design that other parts of the country don't have because they haven't had their regulatory carrots and sticks, I guess. And certainly, the more that we bring these ideas that we're talking about here today into the mainstream, the lower the cost becomes. So there's definitely a place for regulation. And as we advocate for code development, we advocate for state and national policies in our firm. So we believe in the power of regulation if it's done well. So the new Seattle Energy Code is basically phasing out gas for by next month for space heating, and by the end of the year for water heating. And so those kinds of things are very powerful. Anyway, I think it actually spurs innovation. So I think it's all good.
Great.
Yeah, I would just say from ILFI's perspective, it's interesting looking globally, right? There are some regions of Europe where ILFI certification is bumping up against code, right? The building code requirements in the United States are so far behind the rest of the world in many cases. And so there is a huge need for, I think, leadership from that sector, or maybe a huge opportunity for leadership in that sector in the United States. And Jim, I think you're right that those regions of the country that are leading, of the United States that are leading, provide that kind of spur to help kind of kickstart things, right? I think one of the biggest criticisms of really aggressive policy is that there's a fear that it's going to dampen development, or that it's going to dampen economic activity. And I think the opposite is true. Like what we see is that it actually spurs economic activity. It spurs innovation. And so that's also a pretty exciting, feature to it, right? That it's actually, it really does drive competition and aligns incentives in a way that drives us to compete for the right things, right? Who can build the tallest all electric building? Who can build the tallest net zero building? Who can right? Those things start to become mutually beneficially aligned incentives, right? As opposed to kind of fighting against our other interests.
Thanks. There's a question here about distributed energy resources. So I think we've spoken to a lot of specific individual buildings. And I think the question is getting to the point of how do we trade excess renewables locally to provide really demand response to the grid and activate new revenue streams. I know, from our firm and our perspective, we're doing a lot more analysis looking at decarbonization of university campuses. So looking at sort of a district scale to do that. And then I know, we have also been partnering with different cities, looking at the city scale. We're doing a study right now for Washington, D.C., looking at, a carbonization strategy for the city. We've worked with other municipalities to develop some zero carbon action plans. So I know all of that work is in play. And I do think that's important, right? I know the question came up about height earlier. If you look at our really urban cores, if we're looking at New York City and San Francisco, where we have these really, really tall buildings, we run out of roof space for those buildings. And I know the way I've heard it discussed before that I thought resonated really well was that, our cities don't self-support themselves in any other way, right? Like our cities are dependent on an agricultural system that supports them for food and, even a lot of, housing, which fortunately is moving more downtown again. A lot of that resource comes in. We have a lot of distribution of goods coming in. So I think looking at a city scale from an energy standpoint also makes sense, right? Like if you can put rooftop renewables in your suburbs and channel that to support the urban center, that really mirrors a lot of the other flows that support our urban centers. Does anybody else have any, I guess, kind of comments and direct experience? Shawn, again, I know either ILFI has neighborhood scale certification. I guess for the rest of the panelists, do you have experience in your projects or developments at that, a regional scale for achieving some of these electrification decarbonization goals?
I can say that there's a very important role for building-based renewables and also incorporating storage at that level. There's actually some recent research by Christopher Clack that looks at that and sort of determines that it's really a low-cost approach to the transition because it avoids a lot of grid improvements that are costly in many different ways. And I'll say one thing I've seen in the last year. So we have PV associated with some of these buildings, and people have been putting in renewables and sort of trying to meet zero net goals. But I think one of the things that we're doing very well yet is really putting in renewables and storage in a way that makes it a really strong resilience asset. So something, often the PV is installed in a way that it doesn't work when the grid goes down. And so there's work that needs to be done to sort of bring in those microgrid strategies, have it so that parts of the building load can be on solar, when the whole grid goes down, and think about how that relates to backup standby generation and so forth. And I don't see us doing that well yet, but it's coming. And I think that could even improve, the value proposition for renewables. It makes it a lot more complicated, but it will be part of the equation as well.
Right.
And I would just say, I think from the experience that we've seen with, we've got an approach to the certification that we call scale jumping. And the idea behind that is that there are some projects that either because of their specific site constraints or because of other opportunities, right? Shading on one portion of the site where there's areas that are nearby within the same region that can be used for more efficient solar production, right? So we've talked about this with multiple projects where they've been able to expand the footprint of where they're putting solar, neighboring roofs, other properties, remote properties, even investing in like virtual PPAs, power purchase agreements. When we're starting to talk to organizations, large multinational organizations that are buying renewable energy for their entire portfolio, and then working with accounting teams to literally attribute kilowatt by kilowatt to each building that's, and where it's being used. So I think it's both and, right? I mean, I think part of what, from our perspective, the certification requirement of saying, first prove that you can't meet it on site, then we can talk about ways to go off site, right? That's been our approach for all of these projects. And it does two things. One is it drives things like what happened at the Bullitt Center, where it really drives project teams to do the work to focus on passive strategies, to do the work to focus on driving down demand, which we all need to do anyway, right? And in that case, they were able to create enough energy on site. For projects that wouldn't be able to do that, first what it does is it creates an extremely efficient building. And then what it does is it still requires that project team to take responsibility for the energy that they need, right? And so then it starts to create regional opportunities for investment, for ripple effects, for stories. We've got one project that they're in Back Bay, Boston, really shaded site, shaded by a bunch of old trees, made no sense to cut down trees in order to do solar on their property. So they literally went door to door to all their neighbors and said, can we lease your roof space? 3 years later now, pretty much every townhouse on that entire block has solar, right? Because they figured out the structures. So the importance of the goal up front, I think, is really important, right? To be able to hold that level of accountability and rigor drives us to do that those innovative solutions that actually have the impact, right? If we allow ourselves the pass from the very beginning and just say, oh, well, we're in Manhattan, obviously we can't do it, right? Like that short circuits the whole process. And so I think there's a really important role there for the ambitious goal, right? And actually trying the ambitious goal first.
I agree.
Yeah. Oh, sorry, Jasmine, did you want to add something to that?
Oh, no, I completely agree. And we've had some recent very large developments where we consider that holistic impact. And it's an intense process, but it's so necessary. So
great. So there's a question in the chat from somebody who's just at the beginning design phase for a project in Hingham, Massachusetts. Just wondering if there's limits on making projects all electric, if there's a significant cost impact. I might just sort of put this out to the group, and we only have a few minutes left. So maybe as a final question of what are the biggest challenges in trying to do one of these types of buildings that we're talking about that is all electric and also, as we've alluded to, very efficient as well to support that. And how do you get that commitment from the design team up front, Shawn, like you were just describing? So I guess I want to make sure that we get a chance to hear back from some different people. So I guess maybe Jasmine, if we could start with you, maybe even just on that project that you were just telling us about, kind of what are the limits, what's the cost, what are some of the challenges, and how do you get past those?
Yeah, I think cost is obviously the number one thing that developers will think about, or construction teams, but at the end of the day, it is like the developer, the owner requesting for that project to be done. So if they're like, this is within our budget, that's fine. I guess the next biggest thing that I do have a little bit more control over is education. I think while electric and and electrifying buildings is current and is happening now, like we've established in the beginning of this panel. And it's still a little bit new, and it might be a little bit more familiar from like an owner side, but working with design and construction teams, there's a little bit more of that knowledge gap. And so making sure, like I've been working a lot on decarb and embodied carbon reduction, and just making it really clear the needs and requirements of that project or the company or whatever right up front, having that integrative design process from the start, and just understand that it can't be in like bits and pieces. It's day one in the design documents, and just know that like we're all learning and finding the best way as new innovative technologies come out. But yeah, we'll get there. So I think it's just everyone learning together and being willing to work together.
Perfect. And I'm not sure that we'll have time to get to everyone. I think we're actually a minute over at this point. At some point, they're going to kick us out. So since it is a design question, it sounds like it's being asked from a design standpoint. Jim, I might just give you the last word. If you had a word of advice for this person asking the question, to be able to, at the beginning of a design phase, move forward with this, what would you recommend?
Well, I was intrigued by the question because it references a public safety building, and I was going through our portfolio before this talk and trying to figure out which projects we actually had gas on, and 3 of the 5 were actually fire stations. And so there are certain building types that are, they have the kind of end uses that may be, quote, harder to electrify than others. So especially the water heating and the space heating in the at bay of a fire station are kind of challenges, and they're usually done at fairly low budgets under kind of civic budgets. But there are definite examples of those that I could provide. So there are costs on the electric side. I don't think we fully realize the savings that are achieved by not using gas, by not installing gas. So there's a first cost impact, and I think there's also, with the way gas is priced these days, there's definitely an operating cost impact because gas is just such an artificially low price. So I think it's both first cost and operating cost that people are concerned about. And then, obviously there's just kind of a construction momentum. But yeah, so we could get into kind of finer details of, panel sizes and all that stuff, but that's more of an engineering thing than it is an architecture thing.
Yeah, I can say that on the heating side, the heat pump technology has come a long way, even within the last few years, and the costs are coming down to go along with that. So, it is becoming easier to do those, even with the higher end uses. I think where we run into the biggest challenges is trying to convince chefs in commercial kitchens to go with induction. That seems to be our sticking point that we're running into on the engineering side.
We've just gone through that and decided to go with induction, and we use it in our home. It's actually much more controllable, and it's actually quite a good technology.
So again, it comes down to that mindset, right? Getting people to look at things anew and rethink the way we go about things. Yeah. So I think we're at time. I think we were supposed to wrap up at 12:15, and it's 12:18 now. So I know we didn't get through all of the questions. I think all 5 of us would be more than willing to answer questions if folks want to reach out. I think you can get our contact info through the Burridge Electrify registration thing. Portal. So certainly, glad to have everybody here to speak with us. Thank you, John. Thank you, Jasmine. Thank you, Shawn. Thank you, Jim. And thanks everyone for your questions. This was a great conversation.
Thank you. It was a pleasure. Thank you for having me.
Thanks, everyone.
Thank you.
All right.